Good morning to everybody. My name is Jörg Scherer. I'm the coordinator of the European IP Helpdesk, and a big thank you also to Natalia, who gave a perfect overview about all, let's say, the existing IP advisory services funded by the European Commission and the IP action plan, which will like a guiding principle for the years to come. So it's really my pleasure to welcome our participants to this very interesting session focusing on IP challenges for the Green Deal. I think it's beyond question a very crucial and a hot topic in the context of green growth strategies. It is only very recently that the European IP Helpdesk contributed to a commission study on the tech transfer of green technologies. This study will identify bottlenecks and for the transfer and the commercialization of green technologies developed in the public research organizations within the European Union. So the European IP Helpdesk has been involved in this study because there is no doubt technology transfer is closely linked to intellectual property management. IP aspects potentially facilitating or impeding the diffusion of green technologies are key elements of this study, which is currently near finalization. Thus, it is for me with great pleasure to moderate this new or the next session. The main part of the session will be dedicated to 5 case studies presenting different green innovation journeys. The most significant case, let's say the benefit of case studies, because I have to say I'm really a big fan of case studies. The most significant benefit of case studies is that they enable a holistic review. It's not a snapshot with a narrow view on a very specific IP issue. Our case studies today provide the big picture value of a 360-degree IP management practices. So finally, we hope that you connect with our stories and you can benefit from the lessons learned and the main takeaway messages of our IP experts and entrepreneurs presenting today. By this, that brings us then directly to the first case study of today. As a very first speaker, I would like to invite Christian Hackl. He's a member of the European IP Helpdesk team and represents TUM-Tech GmbH in Germany, located in Munich. And I'm very happy to say good morning to Christian. Christian, are you ready?
Yes, Jörg, I'm ready. Thank you very much, Jörg, for your kind introduction. Thanks to Natalia as well. And good morning to all of you, ladies and gentlemen. Welcome here and welcome to my little story about the company Orcan Energy to tell you a little bit about how they approached the topic. Next slide, please. Here we are talking about waste heat as one aspect of clean tech. Waste heat is basically any heat produced in any process, for example, industrial process, which cannot be used anymore, and it's released to the environment, mostly into the air, because it cannot be utilized anymore. I've listed a few of the typical waste heat sources, obviously industrial applications, but also power systems, being it stationary or mobile, for example, also on ships. Typical application also the CHP, the combined heat and power plant, power units, and also renewable power plants like biogas, solar thermal, geothermal, where you basically use renewable energy to produce electricity. They also are a source of waste heat. And as you see on the next one, it's a big topic, waste heat. Can you click on it again, please? Yeah, you see, it's really a tremendous amount on a global scale. It's the equivalent of 100 million liters of diesel produced every single hour across the globe. So this is really a big topic, and that's where the company Orcan Energy comes into play. As you see on the next slide, it's a startup from the Technical University of Munich. It started out as a research group. They found some interesting technical innovations which you could use to address the topic of waste heat. And so a bit more than 10 years ago, they founded their startups, and today there are almost 70 employees in this company. They have a wide IP portfolio consisting of patents, trademarks, registered designs, and they are quite successful, receiving some awards for their design, also for their innovation work. As you can see on the next slide, yes, their goal is to produce electrical power out of this waste heat, which would have been otherwise released into the environment. Well, if you're thinking of the challenge of producing electrical power out of heat, obviously the steam turbine power plant comes to your mind, but this only works for very high temperatures of the waste heat, and waste heat normally does not come with such a high temperature, so steam turbine doesn't really help you very much here. However, there's a different system. It's called ORC, different technology. ORC stands for Organic Rankine Cycle, where you basically use an organic solvent as sort of a transfer medium for the waste heat. And this helps you to utilize energy from waste heat with lower temperatures. So basically, you already achieved the first goal. But these ORC installation tended to be really big one, really big individual installation. So the goal was to find a system which is compact, cost efficient, sort of a product, make a product business. And as you can see on the next picture, just a typical glimpse, this is a typical ORC installation in industry. So it's really huge installation. Next slide, please. So basically the challenge was to go from these huge, big industrial installations, these bespoke installation, go to a standardized product business, and obviously reducing the high engineering workload associated with these bespoke installations. Orcan Energy came up with a few very innovative aspects how to deal with this challenge. And for example, one of them was not to develop all new components from scratch, but really using existing industrial components, meaning these components, they are produced for total different application, but they are produced in high numbers. They have been tested, they're very reliable, and because of the economies of scale, they are much cheaper and much simpler. So this sounds easy, but there are some challenges associated with this aspect. As for example, if you talk to an established manufacturer of these industrial components, you have to convince them that you want to use their components for a total different application. And this means, yes, you have to convince them to do some testing of their components for a total different application. So this was quite a challenging task because these, well, big companies, they said, hey, you young 3 students coming up to me, it just doesn't work, you know, go back, do your homework, read your textbook. The new idea you are having, it just contradicts the typical learning from the textbooks because their aspects, what they had in mind in terms of new innovative technology doesn't work. Unfortunately, we don't have time here to go into the technical details of the new approach. If we have some engineers in our audience, just one topic, cavitation. They had to deal with cavitation. Cavitation can cause a big damage to your technical components, and you want to avoid cavitation for all means. And these young students, they come up with innovative approaches to avoid the capitations, which contradicted the textbook learning back a few years ago. And that's why it was so difficult to talk to established producers of industrial components. And you needed them for the test of their industrial components for the new application. So yes, main message here, it was challenging for them. Next slide, please. Coming to the topic of IP, intellectual property. IP was very important for Orcan for several aspects. The one was, for example, yes, their product was rather easy to reverse engineer. Once you basically had a closer look at how Orcan's approach was to solve the problem, it's rather easy to reverse engineer. So that's why patent protection is really essential. As mentioned before, this ORC process, it's an established technology. It's not an invention of the company Orcan. they used it as a basis and added several sort of innovation to it. So there is no one single patent, for example, for the basic technology like the ORC, but it's a combination of several additional patents. And the new features, for example, the components of the control system, this is a new aspect which they were able to get a patent protection out of this. So basically this whole bundle resulted in currently 23 patent families and more than 100 granted patents around the globe. Next slide. Yes, thank you. As mentioned, it started out as a research group at the university. This means out of these 23 patent families, 8 of them came from the university lab and obviously belonged to the university. So the contact and negotiation with the TTO of the university obviously were a very important point at the beginning of the company Orcan at the startup times. And they brought in the venture capitalist rather early. Venture capital funding was obviously essential for this startup because it took a lot of time and tackling investments, which were very cost intensive. And obviously for a VC, for venture capitalists, the patents are really essential. And therefore it was very important that Orcan was able to get a fast access to the patents and thus was able to make fast decisions, because it may take a while until you convince the venture capitalist that you are a great startup. But once a VC is convinced, they like to move fast. And then you as a startup, you have to move fast. And obviously universities are not so known for fast making decisions. So in this case, it was important for Orcan to move fast, and they were able to get a transfer of ownership of these 8 patents rather than a license deal, allowing them for really fast decision making. And as I mentioned on this slide here, patents are essential for VCs and startups as well. Just 2 more examples. As I mentioned before, it was difficult for the young startup team to go to the established manufacturer of industrial components. They just did not want to listen to them. They said, oh, students, go home, read your textbook. It just doesn't work this way. But once the students were able to say, hey, we got a patent from the European Patent Office, at least their counterpart took the time, sit down, listen to the students, and sort of took the time to get into discussion, and finally were able to be convinced that the new technology of Orcan is very interesting and it would be good for them as established manufacturer of industrial components to team up with the young startup. So it was basically really sort of a quality seal. The patent helped the startup to communicate their technical advantage. And another aspect where the patents at the very beginning were very helpful, Orcan was able to apply and win 2 rather big R&D funding for 2 projects at a very, very early startup time. And again, the patents were very important for them and helped them to win these 2 grants. Okay, next slide, please. So basically, they were successful. They were able to get the ORC technology out of these huge bespoke industrial applications to this sort of standardized business. And here you see their Epec. This is one product to produce electricity out of waste heat using the ORC technology. And as you can see on the next slide, a typical installation here. This is basically a biogas plant. At the very beginning, at the very back side of the building, you see a little bit of the gas dome of the biogas plant in the building with red roof. You see the CHP, the combined heat and power plant. And in the forefront, you see the Epec, Orcan's Epec, which is used to produce electricity out of the waste heat produced by the CHP, which would normally be released into the environment, into the air. And here, Orcan's Epec can take up this waste heat and produce additional electricity. Okay, Very quick look going international, since we are here in a sort of international setting for Orcan. It was a big question how to address large international markets like China. They were too small to cover them on their own. So they had two options: give up a huge potential market or find a good local partner. Good all is basically a partner with a strong market presence in China, for example, and having a common understanding of a technology and doing business. Next slide, please. They teamed up with a Chinese partner, formed a joint venture with this Chinese partner, granted a license for the technology and know-how, but with this license, they were rather selective, keeping some of the core technology to Orcan, at least for the time being, and only giving some sort of less critical technology through this license. And the license was exclusive for Asia and Africa, and as you can see from the manufacturing, marketing, sales, and maintenance. Next slide, please. How it works. Basically, the core components with the core technology, they are being built in Germany by Orcan, then shipped to the joint venture. Other components are added in China. Then the full product is shipped to the customer side, installed by the Chinese partner, because the Chinese partner, they know all of the local demands. And with this setting, they had a very, very big first success, a huge installation in Myanmar, where they had 70 gas turbines of the Chinese partner plus the ORC from Orcan. And so on the next slide, it's basically a summary of the journey of Orcan from the single installations in Germany. Next one, please. As you see on the next two pictures, this product, next one, please. Typical installation, as I told you, one single Epec next to one installation. Click on it, please, again and again. To the large installation in Asia. This is a much, much bigger product of Orcan now, much bigger than the previous smaller installation. And the last picture, as you can see here, that's the huge installation in Myanmar. If you look sort of at the very foreground on the left-hand side with the three sort of round exhaust shapes on it, this would be the gas turbine of the Chinese partner, and sort of these two rows in the middle, that's the Orcan ORCs. And you see, Orcan used to sell one small product at a time, and here they had one project with 70 huge, large products from Orcan. So basically that's it, 15 minutes sharp. If you like to read a little bit more, I had the honor of writing two case studies. The first one for the EPO. You can search for them. If you search EPO and SMEs case studies, you find them. And the second case study on the next slide, it's on the aspect of going international, licensing out to China. It's a case study you find on the European IP Helpdesk. And with this, thank you very much for your attention, and I'm giving back to Jörg.